Alright, so in day 2, what we're going to be doing is talking about another type of special right triangle called the 30, 60, 90 triangle. So let's do some Pythagorean Theorem stuff first so we can kind of get an idea of what's going on. So we have A, B, C, and remember it doesn't matter which side you label A or B. So Pythagorean Theorem says a squared, which we don't know what it is, plus b squared equals c squared. So then we're going to have a squared plus 4 equals 16. Okay, subtract 4 from both sides, a squared equals 12. And then when we square root both sides, we have to simplify the radical. So the square root of 12 can be broken up into the square root of 4 times the square root of 3. Square root of 4 is 2, and then we're left with the square root of 3. So our side here, our a side, is 2 times the square root of 3. Alright, let's look at letter B. A, B, C. So 5 squared plus b squared equals 10 squared. 5 squared is 25 plus b squared equals 100 because 10 squared is 100. Subtract 25 from both sides. So b squared equals 75. Well, when we square root both sides, we need to make sure to break up the radical. I won't do this part just yet. So break up the radical. 75 can be written as 25 times 3. The square root of 25 is 5, and the square root of 3 is going to be left alone. So our answer is 5 times the square root of 3. Alright, we're going to do one more, and then we're going to try to find a pattern if you haven't seen it already. Let's do letter C. So A, B, C. So a squared plus 6 squared equals 12 squared. So a squared plus 36 equals 144. When we subtract 36 from both sides, we get 108. Now the square root of 108. We want to see what is the biggest number that we can divide 108 by. And like I said before, if you can't think of the biggest number, you can start with a smaller number like 4. If I divide 108 by 36, we get 3. So I'm going to square root both sides. The square root of 36 times 3. Now the square root of 36 is 6 times the square root of 3. So this is our answer. So the first thing I want us to look at is, what do you notice about the hypotenuse and the side that is across from the 30-degree angle? So in here, our hypotenuse was 4. The side across from the 30-degree angle is 2. Right, in example B, our hypotenuse is 10. Well, this is our 60-degree angle, which means this must be 30 degrees, because 60 plus 90 plus 30 is 180. And the smaller side, or the side across from 30 degrees, is 5. And then down here, again, this is going to be 30 degrees. The side across from 30 degrees is 6. The hypotenuse is 12. And even in letter D, we didn't solve this one, but the side across from 30 degrees is 3, and the hypotenuse is 6. So in a 30, 60, 90 triangle, the hypotenuse is always 2 times the side that is across the 30 degree angle. So the hypotenuse is 2 times the length of, and it's always the shortest side. The side across from 30 degrees is the shortest side. So the hypotenuse is always 2 times that. Alright, so now let's look about the shortest side and the side across from a 60 degree angle. Okay, so here's, oops, not 30. This is 60 degrees because these 3 angles have to add up to 180. So the side across from the 60 degrees was, oh, this got moved, was 2 times the square root of 3. Well, the shortest side was 2. Alright, in example B, our shortest side was 5. The side across from the 60 degrees was 5 times the square root of 3. Alright, in letter C, the shortest side was 6. The side across from 60 degrees was 6 times the square root of 3. So in letter D, if we apply that same logic, here's the side across from 30 degrees is 3. The side across from 60 degrees would be 3 times the square root of 3. So whatever this value is, whatever the shortest side is, the one that's not touching the 30 degree angle, we got to multiply that by the square root of 3. So let's write the side across from the 60 degree angle is the square root of 3 times the length of the shortest side. So based on that alone, we don't have to do a lot of Pythagorean Theorem anymore. We can use these special right triangles to make things go by a little bit quicker. So if we look at the next page where we have our general rule. So in a 30, 60, 90 triangle, the hypotenuse is 2 times as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So that's what we wrote up there up on the previous page in words. So this down here, this area, is going to be kind of our Bible in what to do given the situation. So the hypotenuse is always 2 times the shorter leg. But what if we're given the hypotenuse and we want to find the shorter leg? Okay, so we would have to take the hypotenuse and divide by 2. If we're trying to find the shorter leg, we divide the hypotenuse by 2. Now the longer leg, if we're trying to figure that out, we would take the shorter leg and multiply it by the square root of 3. And then similarly, if we go backwards, if we're trying to figure out the shorter leg, but we know the longer leg, we would take the longer leg and divide it by the square root of 3. And that's when it might get a little bit ugly is when you're dividing by the square root of 3. You could get a decimal, which is perfectly okay. So let's look at these examples. Well, it looks like in example number 2, the 30 degree, like all my angle markings seem to have disappeared. So let's just fill those in. So we are given the hypotenuse, and we're trying to find the longer leg, and we're trying to find the shorter leg. Now please always go by the math, don't go by the picture and say, well, the orange leg is longer, that's got to be the long leg. The long leg does not touch our 60 degree angle. Our short leg, the green one, that does not touch the 30 degree angle. That's how you tell. Well, if I have the hypotenuse and I'm trying to find the shorter leg, up here we said the shorter leg equals the hypotenuse divided by 2. Well, the hypotenuse is 8, so divide that by 2, we get 4. So the shorter leg is 4. Now, we have to find the longer leg. Here, it says the longer leg is equal to the short leg times the square root of 3. So that means we will take 4 and multiply it by the square root of 3. Don't leave it as don't change this to a decimal, leave it alone. So our answer is 4 times the square root of 3. That's it. Do not make it a decimal. Alright, now letter B. Oops. In letter B, if this is our 60 degree angle, that means this must be 30 degrees. And our long leg is 5 times the square root of 3. We're trying to figure out our short leg and our hypotenuse. Okay, so, whoops. Up here, we have that the shorter leg is equal to the long leg divided by the square root of 3. If we take the long leg and divide it by the square root of 3, these cancel, and we're left with 5. So we get 5 for the short leg. Now, if we're trying to find the hypotenuse is 2 times the shorter leg. Our shorter leg is 5, so 5 times 2 is 10. So the hypotenuse will be 10. Alright, now letter C, this is where it's going to get a little bit confusing, because we have a whole number right here, 7. Okay. So the long leg is 7. The short leg is what we're trying to figure out. And again, the short leg is the long leg divided by the square root of 7. Well, the long leg is 7. So to find the short leg, we need to do 7. We need to do 7 divided by the square root of 3. So this is where people start freaking out, because they say, well, how do we divide by the square root of 3? You can leave it like that or make it a decimal. I would personally just leave it alone. Later on, we will talk about the proper math way to deal with that, but just for today, let's leave it alone. So this is 7 over the square root of 3. So then we have the short leg. The hypotenuse is going to be 2 times that shorter leg. So this hypotenuse will be 2 times 7 over the square root of 3, which will equal 14 over the square root of 3. Because remember, with fractions, you multiply straight across. 2 times 7 is 14. Okay, so up here, this is kind of, like I said, your Bible of what to do. If what you're looking for, you find out what you're looking for, and what you're given, and you use one of these 4 rules. Alright, example 3 will kind of review a little bit from yesterday. So what this is saying is, okay, if x is 18, what does y got to be? Well, in a 45, 45, 90 triangle, remember that the hypotenuse is the square root of 2 times the short leg. So this is going to be 18 times the square root of 2. Alright, then the second column says if we're given that y is 3 times the square root of 6, what does the other sides have to be? So we're going backwards. So we're trying to find the leg. So we need to do this 3 times the square root of 6 divided by the square root of 2. And what this will equal is 3 times the square root of 3, because we can combine these and say the square root of 6 divided by the square root of 2, that's just going to be the square root of 3. So this will be 3 times the square root of 3. Now we look over at today's stuff. Alright, and we go by column. If A is 4, if the shortest side is 4, that means the longer leg has to be 4 times the square root of 3. And then that means the hypotenuse has to be 4 times 2, which is 8. Now the next column says, well, what if B was 4? What if the longest leg was 4? Okay, so now we got to go backwards to find out what A would be. So we'd have to do 4 divided by the square root of 3. And remember, I told you that for today we're going to leave that just like that. So 4 divided by the square root of 3. Okay, so now that we know what the short leg is, we need to multiply that by 2 to find the hypotenuse. So we're going to do 4 over the square root of 3 times 2. That's 8 over the square root of 3. So 8 over the square root of 3. Right, then the last column, they're saying, what if the hypotenuse is 4? So with the hypotenuse is 4, I would go back and find A first. So I would do 4 divided by 2, which is 2. And then to find out what B is, we take the shortest side 2 and multiply it by the square root of 3. So these do get a lot easier, and it is important to know these because on the non-calculator part of the SAT, these special right triangles come up. So you do have to know them. Yes, you can use a calculator at some point, but we got to get ready for your PSAT and SAT.